This is section 12.3. This is on page 146, I believe, from the handout. And what we're going to talk about is what an exponential function is. We'll talk a little bit about what an exponential function is first. We'll go over the definition, and then we'll go over a couple examples with a graph. Okay, so an exponential function is written in this form, a to the x. Now, a has to be positive, and it cannot be equal to 1. The restrictions are that a has to be positive, so it's defined for real numbers, and a equal to 1 is necessary, otherwise it wouldn't be an exponential function. It would just actually be a line, a horizontal line. So, okay, so this first one in the handout, I thought I would do this one right here, 2 to the x, just to kind of give you an idea, because I thought there wasn't one in here. I'm just going to pause for just a second while my dog stops barking. Okay, so I picked values from -3 to 3. I just picked integers, and I'm going to plug them in here to see what the y value would be. So feel free to pause this anytime you need to. Okay, so the first one is -3. So 2 to the -3 is the same thing as 1 over 2 cubed. And then 2 cubed is 8. So this is the same thing as 1/8. If you put that in decimal form, I believe it's 0.125. So I'm going to go ahead and write that down just to make it a little bit easier to graph. So I went ahead and took 1 divided by 8 with my calculator. Okay, 2 to the -2 is the same thing as 1 over 2 squared, which is 1/4. And it, just again, to make it easier to graph, that's 0.25. 2 to the -1 is the same thing as 1/2, which is 0.5. 2 to the 0 is equal to 1. 2 to the 1 is just equal to 2. 2 squared is equal to 4. And then 2 cubed is equal to 8. Again, feel free to pause this anytime you need to. And now I'm going to go ahead and show you the points on here. Oops, sorry about that. Okay, let's it focuses again. There we go. Okay, so just kind of showing these points. The first point is -3.125. So that's about right there. And then we have -2.25. -1.5, that'll be the first one we can actually see. 1.5 would be about right here. 0, 1, they all go through the point 0, 1. You can kind of tell that here. 1, 2, right there. And then 2, 4. And then, I don't know if this one will show up in here, but 3, 8. Oh yeah, it does. Okay. So this graph right here is 2 to the x. They also have a couple other examples, 10 to the x and 3 to the x. Okay, so we kind of talk about that. As the value of a gets larger, the faster it rises. So 2 to the x is the slowest out of these three. 10 to the x is the fastest. Okay, so that's our first example. The next example is where a is between 0 and 1. Just kind of more information if you want to know. If a is greater than 1, then it'll always go up to the left from the right. If a is between 0 and 1, I guess she has it right there, then it should look something like this. It should fall from the left to the right. So just kind of looking at these numbers here. First number they picked is -3. -3. Let me just pause and rewrite that neater. Okay, that's just a little bit neater. Let me kind of zoom in here. Okay, there we go. Okay, so I'm going to actually do this part over here. So this is going to be my y. This is going to show how I got these numbers because I really don't have enough room over here. So I'm going to take 1/2 to this exponent. So 1/2 to the -3rd is the same thing as 2 cubed, which gives me 8. Now I'm going to take 1/2 to the -2nd. And that gives me 2 squared, which is 4. 1/2 to the -1 gives me just 2. 1/2 to the 0 just gives me 1. 1/2 to the 1 just gives me 1/2. And if you want to put that in decimal form, I'm just going to put 0.5 because sometimes that's just easier to graph it that way. 1/2 squared is 1/4. And that's 0.25. And then 1/2 cubed is 1/8. And again, I'll put that as 0.125. Okay. And then just to kind of plot these points here. The first point is -3/8. Okay, so it looks like that's right there, I guess. I already have it marked. This must be the next one. -2/4. Yeah, they already have it on there for us, so that's nice. -1/2. It's right here, and then so forth. Okay. So if it's between 0 and 1, it should be going down. It should be decreasing. If a is greater than 1, it should be increasing. So again, if a is greater than 1, it should be increasing, going up from left to the right. If a is between 0 and 1, it should be going down. So when they talk about exponential growth, this is actually what they're talking about. You know, that means it keeps increasing by some factor, whatever your a is. So this relates to exponential growth, which we've seen in the news recently.